In part 5 of section 3, we're going to be looking at another concept. This one's called the relative extrema. And example 3.8 is going to help us get to discussing the relative extrema, but example 3.8 is also going to give us a really nice review of all the concepts that we've seen thus far. So it says here that we have f being defined from R to R. So it tells us that the domain of this is going to be all real numbers. So we can see pretty clearly that the domain is going to be all real numbers. It states it. I don't have to do anything else with it from the graph. And I can also go ahead and put arrows at the end, down here in the bottom left and also in the bottom right, because the domain says that it should be going beyond the viewable window. So we will need to discuss the range. And from the graph, I need to pick a point to start. I'm going to say let's start right here. And at the point -3, 0, I have a y value of 0. And then I have to choose a direction to go. If I start going down this way, I'm going to pause right here real quick. And the y value there is going to be -5. So everything from 0 to -5. And then if I continue along my curve, I'll continue down forever, which tells me that I'm headed in the -infinity direction. But let's go back to the starting point and let's start going up. So if I go up the curve, I will eventually reach this little peak here, and that peak has a y value of +4. So everything from 0 to 4 needs to be accounted for. And then I go back to the curve and I start going down again. And I eventually get down to this point where I have a little valley. And that valley has a y value of 2. But I already have a line here that represents 2. So 2 is already covered. So let me start going up again. And when I go up, I reach a new height. This is the highest of my little hills, my little peaks, and it has a y value of 5. So now I need to include everything from 4 to 5 in my range. And then as I go across the rest of the curve, I will eventually get back down to the x-axis, which we know has a y value of 0. That also has already been covered, as well as everything in between. And then the rest of the curve also takes me down toward -infinity, which has also been accounted for. So the range, which has to be written from least to greatest, from bottom to top, is going to be written as -infinity to +5, including 5. That will give us the range. Let me clear the graph some. Maybe, there it goes. And I want us to now look at answering some other questions. What are the intercepts of f? So this is a little different than the way that it was presented earlier in the section, because here it doesn't specify x-intercept or y-intercept. So when you see it like this, it means all intercepts. You don't have to discriminate between the x and the y, you just state all of them. So I'm going to mark them. We have 2 x-intercepts where we're crossing the x-axis, and then we have 1 y-intercept where we cross the y-axis, and that's it. And we'll write them as ordered pair. -3, 0, 5, 0. That's the x-intercepts, and then I have a y-intercept at 0, 3. And that's how we'll write them. Now let's go on to increasing and decreasing. So for increasing and decreasing, I want to use red for increasing. I'll use blue for decreasing, and then that'll help us to be able to see the different behaviors that we have. So starting at the bottom left of my graph, because remember we're supposed to read this from left to right, so you want to go as far to the left as you possibly can, which happens to be all the way down here in the third quadrant. I'm going to go up, 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 up until I get to this point. And then I'm going to start to decrease, and I continue to decrease until I get to this point. Now I start increasing again, and then I will decrease the rest of the way through, like that. Okay, so if I want to start thinking of this in terms of x values, the red line that I have, the first one, the first increasing interval along the x-axis looks like this. Negative infinity all the way to -1. My first decreasing interval is from -1 to +2. My second increasing interval is from +2 to 3. And then my last interval, which is decreasing, starts at 3 and it's going to go all the way to the right forever. It's going to always continue to decrease. So now we're going to take these intervals and put them into the appropriate place. Now I know part D says intervals of increasing and part E says decreasing, but it's only natural to do them both at the same time. So we're covering both of these parts here at once. So we're going to write for increasing, the first interval is negative infinity to -1. And then there's another one of those increasing intervals from 2 to 3. And then we'll connect those with the union. Decreasing, we have an interval from -1 to 1. Or sorry, not -1 to 1. It'll be -1 to 2. Let me fix that. -1 to 2. And then we're going to be decreasing also from 3 to infinity. So we're using the x-axis to help us to be able to describe the increasing and decreasing behavior that we see. In the next part, it says solve, and we have an inequality. F of x is greater than or equal to 0. So let me remind you again of what we're saying here. If I'm talking about the equal to part, then the arrow map helps out quite a bit. The arrow map would say what x value needs to map to 0. Well, we already have all those things figured out. -3 maps to 0 and 5 maps to 0. I don't want to use that third point because that would say 0 maps to 3. That's not what I'm looking for. Let me clean off the graph. And let me go ahead and mark the two x-intercepts because these are the places where we're going to have the equal to 0 condition. But I would also like to be able to account for the greater than 0 portion. So where are all the points where the y value is going to be greater than 0? Well, that's going to be everything that is above the x-axis. All of these points that I'm highlighting are going to have a y value or an f of x value that's greater than 0. So if I take what I have highlighted here in red and I translate that down to the horizontal axis, that would be everything from -3 all the way to +5. So our solution set is going to contain an infinite number of x values. So we're going to use interval notation, and we'll put hard bracket -3 and hard bracket here at 5. Hard bracket is that square bracket, and that would represent all of the x values that would give us a y value that is either greater than or equal to 0. For the last part of this example, I want us to talk about the idea of relative extrema. When we talk about extrema, we're talking about extreme y values. So going back to the increasing decreasing concept, let me go ahead and mark those again. Increasing to here, we were also increasing from 2 to 3, decreasing from -1 to 2, and then decreasing from 3 to infinity. So I wanted to mark those again. Where we have the transition points in between the increasing decreasing and decreasing increasing, these are the places that we call relative extrema. Now they aren't the absolute extrema, but they are going to create their own little hills and valleys throughout the curve. So these points would be at -1, 4, 2, 2, as well as 3, 5. Those would be the relative extrema. So we can write these as ordered pair, and we'll list them kind of like what we do with the increasing decreasing. I will state relative max, I'm just abbreviating there, and then I will also say relative min. So the relative maximums are the places where we go from increasing to decreasing. They will be specifically these purple points here and here. Those are the tops of the hill, if you can say it that way. So we have one relative max located at -1,4, and there's another relative max located at 3,5. These are ordered pair, not intervals. Be sure to keep that clear. These are ordered pair and not intervals. And then the relative minimum would be located at that green point, which is the ordered pair 2, 2. And these are your relative extrema.